Hi, welcome to another edition of Antique Radio Archaeology. Today we begin yet another basket case radio, similar to the situation we had with the Chelsea 110 receiver that we did not too far in the past, but this one is much worse. What I mean by that is, like the 110, we are starting with a cabinet and a faceplate. But unlike the 110, I'm unable to find any existing example of this amplifier. Along with the fact that it was likely a short-run amplifier, there are probably very few that were ever produced or exist today. First, let's get started on what we do know about the amp. In 1924, the Shepherd stores posted an advertisement stating that they are selling a 4-tube, 2-unit radio amplifier set that the manufacturer is liquidating because they are manufacturing the pair into a single cabinet. So the Shepherd stores bought the entire supply of them. Since this set has 4 tubes and the Chelsea Radio Company only produced one 4-tube set, I would be making a valid assumption that the radio produced from these two is actually the model 107. As such, it should be just a simple matter of looking at the 107 and breaking it down into a separate tuner and amplifier. So, using this information, I was able to make some further assumptions. Since this is a 2-stage amplifier, 2 of the 4 tubes would be part of the amplifier along with 2 transformers. The 2 transformers are likely as there are 2 sets of holes in the faceplate that match the spacing of the Model 50 transformer. The Model 107 mounted the transformers on the faceplate as well, so this makes sense. Now, with this circuitry, that would create a 2-knob amplifier with phone jacks for the detector, first stage of amplification, and second stage of amplification. So, following how the 107 was built, it would be safe to assume that inside the amplifier there would also be a terminal strip for power. Now, this is where it gets tricky. Now, following the Chelsea radio standard production methods, if you could use that term, the number of holes drilled in the cabinet for wire pass-throughs always matched the number of wires entering the cabinet. Now, since this cabinet has 8 wire holes, it would be safe to assume that the terminal strip would have 8 terminals, which is actually overkill, as the jacks on the front panel could have actually eliminated 4 of them. But I guess they wanted to give the customer the option to use phone jacks or terminals, so that will have to be kept in mind when coming up with a schematic. So, with all the information I had available, here is the schematic I came up with for the Model 113 amplifier. So this should give me enough information now to come up with a parts list and component layout. Now, unfortunately, there's no known tuner in existence, so there might be a couple out there somewhere, but I've never been able to locate one, picture one, other than what's on the Shepherd store advertisement. Since there's no part number on the ad, using the information from my own personal radio catalog, I would say there's a pretty good chance that this is a Model 112 tuner. Now, it could be a Model 105 or 106, but that just doesn't sound right. And with all the other model numbers that have already been used, from 101 all the way up through 113, it was not likely that they would use a higher model number for the tuner. So, based on the ad, here is what I came up with as far as what it might look like. And as such, I can only assume that what the schematic would look like, but that will be our project for another day. So let's just take a look at what we have here and come up with a plan on how to bring this amplifier back to life. Alright, so here's what we have. Now, when I first got this faceplate wasn't exactly this clean. It looked kind of dirty and nasty. I did clean it up several years ago and just screwed it back on. It's been sitting ever since. I did throw some knobs and stuff on it just to make it look like a radio for a while, just to kind of display it that way. But this is pretty much what I got, was a empty box with a faceplate. And here are the 8 holes I was talking about in the back. And obviously we have a detector, first and second stage of amplification. These are the holes that match the Model 51 transformers. So I need to come up with some rheostats, some tube sockets, and of course the terminal strip that's going to go inside. Now, one thing I wanted to point out, if you look here, you can see what looks like there was some wood there, and I'm pretty sure there was. You can see it on both sides. There's also a hole down here. I don't quite know how that figures into this. I'm going to have to look at that a little better. But that's pretty much all I have. Now, I do want to show you the Model 104 receiver. This one here has a terminal strip in it. And I initially thought that it's possible that the receiver was the matching receiver for this, but that doesn't coincide with what the Shepherd ad is saying about being 4 tubes. So nice assumption, but the good thing is this amplifier will work with this, so I can still use it in that configuration, and they will look like a matching pair. So that's pretty interesting. I have an idea now of what I need to do as far as acquiring parts and knobs and things like that, so I'm going to try and find a couple of knobs that are this size and some jacks, and we'll get I've got transformers for it already, the rheostats and the terminal strip. So we got our work cut out for us. So the first thing I want to do in this process is get this cabinet squared away, so I'm going to go ahead and pull the faceplate off of it. I am going to have to fabricate that brace that goes across the top, and we'll figure out what to do with the stuff down below. Now, as far as this brace, oops, I believe it's going to be the same as this one here. The thickness is the same. If you look, this thing kind of ends and it looks like there's another additional piece there. Same holds true on this side. So what I'm thinking is it's probably the same situation as this. You have a piece across and then you have these little braces in the corners. So I'm going to go ahead and do this one like this. So let's go ahead and do that. I'm also going to they used some crappy glue on this thing at one point. Some kind of wood glue or something. Oh no. It's, oh gee, I know what this is. They used hot glue to glue the cabinet together. Oh man, that's gonna suck. Trying to sand that out, but okay, no biggie. We gotta do what we gotta do. Dang, I wish I hadn't have done that. So I went ahead and took the top off a ZR4. It was a spare top. It was busted up on the back of it. So I cut that piece off, and I went ahead and cut a strip off it that's a 1/2 inch thick. A couple of them actually. And this one I'm going to use later on another radio. But this is the one that I'm going to use on this one. I went ahead and cut it to my 10 inches here and sanded it down, so I'm ready to go ahead and glue it in place. And I also have the little corner pieces that I cut off of the scrap material that was left over. So let's go ahead and do that real quick. So I'd like to go ahead and get started on this front panel. There are a couple things that are going on here. All I'm going to do really is populate the front panel right now. There's still a couple things that need to be done, but one of the things I wanted to point out is I could not get Chelsea rheostats, so I substituted this. And the problem that you run into with Chelsea rheostats is the hole spacing from here to here on a Chelsea rheostat is 1¼ inches. Most rheostats have 1-inch hole spacing. So that causes a lot of problems in trying to find a replacement. So what I'm going to do in this instance, instead of using the mounting screws, I'm just going to use a shaft type mounting on this one, so that will take care of my spacing issue. But that's also going to leave holes in the panel, but I don't care. I'd rather have it working than sit here and wait for 10 years to find the right rheostat. So let's go ahead and get started on putting this back together. So I went ahead and fabricated some brackets. that are going to go on a terminal board, which is going to sit right about here. Now what I did was these little L brackets are going to attach to these bolts that are holding the transformer in. So I'm going to have one here and one here, and they are going to bolt to where the terminals are for the loudspeaker and the A-. So that should hold everything in place. And this is in the spirit of how Chelsea has been doing these terminal boards in their radios. They always attach to something that is logical, and that is very logical right there, and I think that's the way they would have done it originally. So you need to get some longer screws, and we're going to go ahead and attach this. Okay, so I found a couple of temporary screws. Temporary as in I ordered a couple of oval head screws that are going to be the right length. These are actually a little longer than what I wanted, but they're going to work for now. So I spent an entire day yesterday pretty much figuring out what bus bars I needed and what wires I needed, and went ahead and prefabricated them. Now the challenge was trying to figure out how Chelsea would have done this, and I did that by looking at the Model 107 radio and seeing what bus bars were used there, and tried to kind of replicate as much of that as possible. So I think I came up with a pretty good idea how they might have wired this, so let's go ahead and get this thing fully assembled. So I went ahead and hooked everything up, tried it out. It does work. So now I'm going to go ahead and disassemble it. I want to take this part off, and I'm going to go ahead and clean it up, label it, and finish it up. So that'll be the final touch before we go ahead and put this thing back in its case and call it done. So before we get started, I'm going to go ahead and go over the schematic, and we're going to talk a little bit about why some of the decisions were made that were made. Now, first of all, the Chelsea Model 113, as you know, there's very little information on it other than the fact that it was replaced along with its tuner with a 4-tube radio, which is the Model 107. As such, I was able to pretty much come up with a layout and a schematic that mimicked what was in the 107. Now, knowing what I know about the layout, I do know that these two holes on each side fit the transformers perfectly. I also know that these are where the jacks are going to go and these are where the rheostats were going to go. So that gave me an idea what the faceplate was going to look like on the inside. Now, I do know that the tubes are always mounted on a little plate, and based on the 107, there is a bracket that hooks to the front. Now that explains this little hole that was down here. So that kind of made sense. And then I knew that there was going to be a terminal board inside. Now, based on the fact that there are 8 holes in this cabinet, that tells me there were going to be 8 terminals, because Chelsea always put the same number of holes in the cabinet as there were terminals on the board inside for some of their other models. So it was all kind of coming together based on information that I already had. So using that information, I was able to come out with the layout that I did. Now, Chelsea liked to use a lot of bus bars, especially on the terminal plates. So using all the bus bars that I did and coming up with brackets that went over the transformer. Now, I don't know about the height of this. It could have been lower in the original. I just know that it was more than likely attached by transformers where the transformer connection points were on the faceplate. So that allowed me to make brackets coming off the transformers going up. So everything had a reason as to why it was laid out that way. Now, as far as how this thing operates, it's actually a pretty simple amplifier, but it was made complex by the jacks. So let me explain. You got your detector input coming in here. Now it's going to go with nothing in that jack. It's going to go right straight to that first coil of transformer T1. Now, if you were to insert a jack in there, you would be inserting an input there. And that would disconnect the two terminals at top, and it would allow you to go ahead and inject the signal that way. Now, once it goes through the transformer, there's going to be about a 1 to 5 amplification, and then you're going to hit the tube. And the grid on T1 is going to pass it through the plate, and then you're going to go to the second stage. Now this is where you would actually have a headphone. So the first stage is really kind of like a headphone jack. So, and with nothing in it, it passes it straight to the next transformer. If you want to hear something in the headphones, you just insert the headphones and it'll disconnect the rest of the circuit. Now, again, 5 to 1 amplification, plus the amplification of that tube, plus you're going into the second tube through the grid, and then out through the plate circuit. Now, the plate circuit is going to get its B+, along with the B+ going to the plate circuit of T1 through the B+ bus here, and it's going to pass through those jacks getting back to the plate, or if you insert a plug, then the B+ will go to the headphone here, it will go to the speaker here. So that's how that particular part of the circuit operates. The filaments are getting, basically you have wipers on A-, and you got your A+ B- feeding the filament circuit, going to the rheostat here, and to this rheostat there. So that's pretty much it. Very simple amplifier, but again, made complex by the jacks. So I went ahead and I paired this 110 receiver with the 113 amplifier because it's part of this engineering thread that led to the Model 107. It's also a later version of, I believe, the 112, and the 115 would be a later version of the 113 amplifier. So as such, I went ahead and paired it with this. Let's go ahead and see how she sounds. Okay, it does work quite well on the headphones. So this concludes yet another episode of Antique Radio Archaeology. I hope you enjoyed today's video, and I hope to see you again next video. Happy restorations, everybody.